Hello everyone, this is day 2, problem 1 of our Leetcode activity. Given a non-empty array of integers, every element appears twice except for one. Find that single one. Let us ignore the second line for now and just understand what the question is. It's fairly straightforward. Here you can get it through example. Here 4 appears once, 1 and 2 appear twice. So 4 is our output. Here, same, 2 appears twice and 1 just appears one time. So 1 is our output. So, what is the first approach which I thought of without reading this second line, that we have to do it in linear runtime? So, most naive approach which I could think of was this, which was, here is the pseudo code for it. First of all, sort the array in ascending order or descending order. The order doesn't matter, but we have to sort the array. And here is the array size. Now we run a loop for I 0 to n minus 1. If nums I is not equal to nums I plus 1, we return nums I. And if this is false, we again run the loop incrementing I by 2. And if the loop gets over its boundary and we happen to find no condition which satisfies this, we return nums n minus 1. Now, why this works? Example, n is 7. Now, if we sort this array, there are two situations, A, B, B, C, C, D. Or let us say D is less than C, then it is A, B, B, D, C, C. So, when we run this loop, think of I, what are the values which I takes? Firstly, it takes 0 initially, then it takes 2 because we are incrementing by 2, then it's 4. When it reaches 6, we have said just run it to, let me fix this, I less than n minus 1. So 6 less than 6 is false, so the loop will stop. Now let us see this condition for 1. What will happen? If first is 1 2, so 0 1, sorry, so 0 1, nums I not equal to nums I plus 1. So a not equal to a is false, so it will not enter this if statement and the loop will run again. Same for 2 3 and same for CC. Now when it reaches CC, this i's value was 4. Now when it becomes 6, loop will end as 6, n minus 1 is 6, as our 7 is n is 7. So 6 less than 6 is false. And it will return nums n minus 1. What is nums n minus 1? This is the last index. Value at the last index of the array, which was D. And indeed that was our single value. Now let us see the second example in which D is not at the end. Now let us run the same loop for 1 0 0 1. Here A same, run the loop again. BB same, run the loop again. DC, here DC are different, so we will return nums I. So this was the third iteration, so I is 4, which is D, so we will return num psi d, which is again the correct answer. This is the single element which appears just once. Now, how does this work? This just works purely based on sorting the array first. As we have sorted the array, we have bundled all the like terms together, either this way or either this way. Now, if d has the single element has the highest value, it will always be at the last. So this loop will not return anything and the last element will be returned. But if the single element has value less than the largest element which appears twice, this loop will ensure that that number is returned. And why it is always the first element of this I and I plus 1, why I'm always returning the first element? Because think of it, always the like terms will be bundled in two pairs, like in pairs. So a b b b. So whichever is unlike will come first, as we are incrementing by 2. So it will always be the first element of our pair I and I plus 1, because the next term will again be bundled with its like term. So this is a naive approach which we can use. This is also a great approach to use, but the question demands to do this in linear runtime. Let's see what is the time complexity for this. So that will be O of n, yn, cause we are running this loop. So we are iterating through each number. So the high, what is the maximum or the worst situation? We iterate the whole array which is n. So this is n, and also we have sorted the array. So this will be n, and sorting the array through the function sort, which we have in C++, is takes log n time. So the final time complexity comes out to be n log n, and the question demands linear runtime. Here it is said linear runtime complexity. So for linear runtime complexity, we need to take the second approach. The second approach is the XOR method. So now, to know XOR method, you need to know XOR properties, which I have written here. First of all, we can exchange any pair in this equation and it still holds. And this is due to two properties. First of all, XOR is commutative, and also XOR is associative. So, combining these two properties, we can adjust XOR equations such way. Second thing, A XOR 0 is A. So 0 is identity for XOR, and A XOR A is 0. So it is self-inverse property of XOR. What does this do? So what we will do, we will take initialize x to 0, n again is the array size. So for I from n 0 to I less than n, XOR x to num psi, and we'll actually return x. So how does this work actually? Here let us see through the same example A, B, C, A, B, D. So when we XOR entire everything as A XOR A, is equal to 0 and A XOR 0 is A. Every pair cancels out just to give us the single number directly. So what we are saying is when I do A XOR B XOR C XOR C XOR A XOR B XOR D. This is what we are doing here. So now, as I have shown earlier, we can write this as A XOR A XOR B XOR B XOR C XOR C and XOR D. Now you can see that A XOR A here this will become 0, B XOR B this will become 0, C XOR C this will become 0. So what will remain is 0 XOR D, and A XOR 0 is A. So this will directly give us D as X and will at last return X. And this is the approach needed for the question, as the time complexity here will be O of n, cause we are just performing simple bitwise operation and we are iterating every element of the array. So one iteration, one traversal of the array is O of n time. So this is the approach, the two approaches for the question single number. And here this is the implementation in C++ for the first approach. Here we have sorted the array. We take n as the size or the number of elements in nums. Run the loop from 0 to the last element, 0 to n minus 1. Why n minus 1 and not n? Because when n minus 1 will be I, here will be n minus 1. So here it will be n minus 2 and here will be n minus 1. And once this becomes n minus 1, the loop will end, and that is the correct way, cause n here it will be n nums of n minus 1, but here it will nums of n, which is not defined cause it is out of the bound of our index. And we increment I by 2, check nums I not equal to nums I plus 1. If yes, return nums I, and if this all things is not satisfied, return n nums n minus 1, which is the last element. So the second approach which I talked about was this. So this is the C++ implementation for that. Int x, int n equals num dot size. We iterate through each and every element and just XOR everything. At last, just the single element remains and we return that element. Thank you.